Hello everyone, welcome back. This is a new lecture in your course Advanced JavaScript from Avionics. My name is Ahmed. In the previous lecture, we have studied the primitive data types in JavaScript. Now let's start discussing each one of them in some more detail. As we said, the number data type in JavaScript refers to anything that looks like a number. Whether it is a floating point number, a decimal, an integer, or whatever, JavaScript does not have that line of distinction between different number data types. They are all treated the same. They are all numbers. However, some people may fall into constructing numbers programmatically in their code. For example, they are placing a number beside a number in order to construct a number variable, and in some cases that number might happen to be a zero. And this is the problem, because in natural mathematics, if you are dealing in a human language, for example in English, when you say 0, 22, okay, this means 22 because any 0 at left of the number is not of any significance. If I say 0, 22, this means that I am referring to the number 22. But in JavaScript, things are a little different. If I type 022, as you can see here, the console has output to me 18. So why is that? This is because 0 at the start of an integer has a special meaning in JavaScript. It means that this number should be treated as an octal number and not as a decimal number. So what is an octal number? The octal number format is just one of the many formats that computers use to deal with numbers. We have the decimal numbering system, which is the one that humans use, which contains the numbers starting from 0 to 9. And we have also the binary numbering system, which is used by computers. In the binary number system, you have only 0 or 1. You have no numbers but 0 and 1. We have also the octal numbering system, which has only 8 numbers. It starts from 0 to 7. And we also have the hexadecimal numbering format, which is 16 numbers. All these are numbering systems. We are not going to study them. We don't have to study them. Just you have to know that JavaScript honors these numbering formats, and it uses some special forms of numbers in order to identify a numbering system from another. So if I place 0 before a number, this means that I am intending to use the octal numbering system. I am instructing JavaScript to regard this number as an octal numbering system. So if you have a calculator and if you switch to the scientific mode, just try that now. Open up your calculator and view the scientific mode of that calculator and go to the octal numbering system and type 0 followed by 2 followed by 2, and then click on the decimal numbering system in order to convert it to the decimal numbering system, which is the human readable numbering system, and you will find that it is 18. Okay, so this is a very important aspect of numbers in JavaScript, and I've seen many people fall into this mistake. I myself fell into this mistake once when I wrote code in JavaScript and I had to construct a number from different variables. I grabbed numbers from different sources and I wanted to formulate one large number by just placing digits beside each other, and I found that if the first digit in the number is 0, things don't go as they are expected. 0 is not treated as 0, which means nothing of significance. It is treated as an indication that the whole number will be treated in the octal numbering system, which of course caused very unexpected results. So beware of the first digit in your number. If it is 0, then JavaScript is going to treat the whole number as an octal number. If you want to work in hexadecimal, for example, if you wrote a web application that deals with, let's say, CSS coloring schemes, if you have worked in web development before, you for sure know that this combination of characters, those 6 Fs in CSS, means the number white. The white color in CSS is represented by these hexadecimal Fs. It's just 6 Fs beside each other. If you want JavaScript to interpret your numbers or characters, because in the hexadecimal numbering system we have numbers and characters, both of them are treated as numbers. So if you want JavaScript to treat the combination of characters as a hexadecimal number, you will have to start the whole number with 0 followed by the letter X. So for example, if I type if I type 0 followed by x followed by 1, 2, 3, 4, 5, 6, as you can see here, this is a hexadecimal number that is transformed to this huge number. This is like about 16 million something. Okay, this is the decimal representation of this hexadecimal number. You can try along and pass in any combination of letters and numbers. And as you can see here, whatever I pass in preceded by 0x will be treated as a hexadecimal number, and it will give me the decimal representation of it. Okay, and JavaScript also uses and honors the exponential notation mode of writing numbers. You know, when you used to study mathematics, you learned that you can write very large numbers in some sort of a shorthand using the e symbol, like this. For example, 1.5e plus 7, like this. And you can either write plus 7 or just omit the plus sign, and it will give you the same results. Okay, this means, this shorthand means 1.5 multiplied by 10 and to the power of 7. So it's 10 followed by 7 zeros. Sorry, it's 10 followed by 6 zeros. It's 1 followed by 7 zeros. So it's like this. Okay, this is the same number that we have if we write 1.5 E7. However, I prefer the longer way of writing it. It's 1.5 E plus 7, and we are going to see why in a moment. Okay, it gives us the same results. If I type 1.3456 E plus 6, it will give me that number. Why? Because it's 1.2345 times 1 followed by 6 zeros. It's the same as writing this. 1 followed by 1, 2, 3, 4, 5, 6. And it has given me the same number. So this is just a way of writing huge numbers like this in some sort of a shorthand. And this is often used in scientific operations. People who write, for example, long equations in mathematical and scientific, perhaps astrological equations or studies, they used to write huge numbers that, for example, calculates distances between planets and so on. So they have to use some sort of a shorthand in order to improve the readability of the documents and save themselves some keystrokes. So they use the scientific format or the exponential format in order to write large numbers, as we can see here, and JavaScript honors this numbering scheme. Now let's see why we have written E with the long form, which is E plus 7, instead of writing just E7, and it would have worked the same way. Well, that's because I do have another method of writing scientific numbers like this. E minus, for example, let's say 3. Okay? As you can see here, the result is completely different. Why? Because this works the other way around. This is the same as 1.5 times 10 to the power of negative 3. And if you remember from the mathematics class, if the power or the exponent of the number is having a negative sign, this means that I am dividing 1 by this number instead of 1 followed by 1, 2, 3, it is 1 divided by 1, 1, 2, 3. As you can see here, it is the same result. So the 3 here represents the number of zeros that will be before this number. So this will be 15 preceded by 3 zeros, 0.0015. Okay, so this is how JavaScript deals with different types of numbers. And these are not actually types of numbers. These are just numbering schemes. The hexadecimal, the octal, the binary, and the exponential numbering. These are not types of numbers. These are just schemes or numbering systems that JavaScript honors when it deals with the numbers data type. Now, before we leave numbers, let's have a look at 2 important types of numbers that we haven't covered yet, the infinity and nan. Everything has limits. That's true. Everything in the world has limits. And JavaScript is not an exception. JavaScript can handle numbers only to an upper limit and a lower limit. This upper limit is this huge number that you see on the screen. You do not have to memorize it, and you shouldn't memorize it because it can be brought by this statement in JavaScript, number dot max value. Let's have a look here at our console. Let's type number dot, and in all caps, max value. As you can see here, it got auto-completed for us. Number.maximum value is the largest number ever that JavaScript can handle. And as you can see here, it is a huge number. It is a very, very, very large number. It is this number followed by or multiplied by 1, and at the right of this one is 308 zeros. This is just a number that I cannot imagine somebody can get even near it. So JavaScript has a very generous upper limit for numbers. You can rest assured that whatever mathematical operations you're going to use will be handled correctly and effectively by JavaScript. And it also has a minimum value, the smallest number that JavaScript can handle, and this is, as you can see here, min value is the same as max, but instead of max you type min underscore value, and it's 5e minus 324, which means 5 multiplied by 1 divided by 10 followed by 323 zeros. Again, it is a very, very, very small number that I don't imagine anybody can get even near this number. So these are the upper and lower limits of JavaScript, but they are referred to as infinity and minus infinity. If you type of and you type infinity, this is a special variable name. Infinity is a built-in variable name in JavaScript, and it refers to this number, just this number. If you type of infinity, it is a number. This is considered a number, and it refers to this huge number. And the same thing holds if you type minus infinity. It is also a number that refers to that minimum value that JavaScript is capable of working with. Now, never try to use infinity or minus infinity in mathematical operations. Some people may be tempted to try to say, okay, let's see how I can use infinity to try to fool JavaScript into working with some more numbers or larger numbers than it can handle. So I'm gonna type 2 times infinity, expecting that I will get double this number, but I'm sorry to disappoint you. I'm not going to get anything. I'm just going to get infinity as a result. And finally, we have the nan, and nan is short for not a number. Nan is just a way that JavaScript informs the developer or the user that the output that it is going to return is not a number. Maybe the developer or the user was expecting to find a number. Maybe the operation that has been executed was expected to be returning a number, but because something went wrong in this operation, something went in an unexpected way, it returned a nan. In order to illustrate this, let's see, for example, what happens if we try to multiply 2 strings together. Let's say A, which is a string, multiplied by B. This is an illegal operation in all manners. You cannot multiply strings. You can actually concatenate strings using the plus sign, as we are going to see in the next slide, but you cannot multiply them. They will give you a nan, not a number. Why not a number? Why not, for example, null, or why it did not give undefined? Because nan, actually, if you type of nan, nan is a number. It is a type of numbers in JavaScript, and that makes sense because the multiplication or the multiply operator in JavaScript is supposed to work with numbers. So the moment JavaScript saw this operator in your equation, it tried to convert these 2 operands into numbers and tried to execute the operation. But since it didn't and it couldn't convert A to a number, because A does not represent any number whatsoever, and B, the same thing, does not represent any numbers, so the result was a number, because the type of operation was multiplication that should work on numbers, but because nothing could be returned, it's a nan or not a number. You will see nan in your code whenever JavaScript was trying to perform a mathematical operation or an operation that should yield a number, but for some reason it couldn't. And again, nan is like infinity. It is a built-in variable in JavaScript, and it is of type number. Now, in the next lecture, we are going to deal with strings, so stay tuned.